Sorry. It's 4:40 in the morning. I need some coffee. Anyway, how about you? Are you up at 4:40 in the morning? Gosh, I hope not. Yeah. The older I get, the more I feel like my grandmother, where you go to bed when it's still light out, and you get up when, like, not even the animals awake yet. You have to wake my dogs up. That's bad. Anyway, you're not here to hear me complain or listen to me watch me listen to me. I don't even know what I'm saying. This should be good. Unit 4-1. Yay! We're like almost halfway through. There's 10 units. This is unit 4. So that'd be like 40% of the way through the class. Oh my gosh. So that means it's got to be probably somewhere around Christmas. Hope you've been good. Santa's coming. Oh my god. By the way, all of this stuff can be found at www.nkinfinity.com. My name is Mr. Krause, but I go by Mr. Key when I make the answer keys up, even though my handwriting is horrific. All right, we're going to work on that, though. Not. Let's see if I can blow these suckers up. So you'll notice that we keep coming back to certain themes, domain, range, getting good handle on that. Today we're going to talk about a lot of domain and range. We're going to talk about end behavior, graphing polynomials of different degrees and functions. So fun. By the way, if you have not hit the subscribe button and you're sitting there going, geez, I wonder if I should hit that red subscribe button. I like Mr. Krause. He's really helped me out. Maybe I should help him out by hitting the subscribe button. The answer is, duh. Anyway, you could graph this using your graphing calculator. I will not, at least in this case, because it's relatively easy. It's got a y-intercept of -1. And again, I'm just sketching it. See where it says just sketch? So I don't have to get an exact thing of that this looks like. And it's got a positive slope of 2. So I would go up 2 and over 1. So up 2, there's my y-intercept. So I go up 2, ching, and wow, that is not really good. So over, yeah, see, that's not even good. Because my scale's so messed up, it's going to look messed up there. We're going to go over 1. So up 1, 2, over 1, something like this. Whatever. Anyway, you get the idea. So a linear function, this is a linear function, just creates a straight line, has a domain from -infinity to +infinity. Remember, domain goes from left to right. You know, how much is it going this way and how much is it going this way? Generally, when you have arrows and they've got even the slightest bit of upward movement, it's going to be, or left and right movement, it's going to be -infinity to +infinity. Again, it's going forever and ever up and forever and ever down. So my range is -infinity to +infinity. Now the number of roots or solutions to this is the number of times here it's going to cross the x-axis. So in this case, it's just 1. Ooh, that was tough. Let's go to this one. So this one, this is a much more difficult problem because it has a y-intercept of -1. But now we're going down to, by the way, I'm just kidding about being more difficult. We're going down 2 into the right one, down 2 into the right one. And again, we just want to sketch. So as long as I get a good quick sketch, oh man, it is so difficult to hit points on a graph. I'm going to need that in a second. So again, it goes forever and ever. Let me get this thing away from my big bald head. Come on. It goes forever and ever to the left and right, so -infinity to +infinity, -infinity to +infinity, and it hits the x-axis once. So one solution. What is that solution? In this case, it's -1/2, but you know, maybe you don't know it, maybe you do know it. I don't know. We're not ready for that yet. Oh yeah, maybe we are. All right, so here's what I know about this one. I know it has a y-intercept of -1. I could probably sketch this without the graphing calculator because I know it has a y-intercept of -1. What I don't know is if it does this. And I know it's going up. So I know it's going to hit this x-axis, or hit the y-axis right here, and I know it's going up. I don't know if it looks like this. I don't know if it looks like this. I don't know if it looks like this. I don't know exactly what it looks like until I actually graph it. I know it's skinny, so it's probably not this one. And it's probably not this one. It's probably this one because it's skinny. What I mean by skinny is it's got a dilation of 2, so instead of being just a normal parabola, it's going to be a little bit skinnier. But let's get a quick sketch of it. Let's look like beep. So I think it was 2. I don't remember what it is. I have it on my sheet. 2x squared plus 2x plus 1 or minus 1. 2. Oh yeah, you're just going to go crazy on me, aren't you? Come on. All right. This is a glitch between my... I don't know what's going on. So we're going to get rid of that. Yeah, that's a little glitch between my pen software and my computer software. It doesn't happen on the computer unless I'm using that pen. Come on, I ain't got all day. Hopefully this works. Anyway, we need to know, for domain and range, I know it's going to look something like this. Something like this. So it is going forever and ever to the right, and it is going forever and ever to the left. So as far as the domain goes, the domain is negative infinity to positive infinity. I know that's going to be true. The other thing I know about range, just based on the graph, just based on the fact that it's got a positive leading coefficient. That means it's going to be pointing upward. So I know that, I don't know what the bottom value of the range is. That's what I'm going to need my calculator for. But I know the top value of my range is going to be positive infinity. I just don't know what this bottom one is. And it's going to be a bracket because it's going to equal something. But I should know that very soon. Well, I think I got it back up. Let's see. All right. Graph. 2x squared plus 2x minus 1. Enter. All right, so it's about what I thought it was going to look like. The only thing I need to find out is what is that vertex? What is that turning point? Because that is vital for the range. Absolutely vital for the range. So a couple different ways to do that. I can go to menu, analyze graph. Probably the easiest way is just find the minimum. Remember, we're going to click on the left, click on the right, and now remember, range, and this is why we keep coming back to this, because I want to make sure you understand the range of this function. The range of this function is the y values. So the lowest y value, I don't care about the x value. The x value is negative a half, but the lowest y value is negative 1.5. So that's the lowest it's going to go. That's the minimum of this graph. So over here, it's going to be negative 1.5 to infinity. And my graph is relatively accurate if I put that mark right there. Okay, let's take a look at this baby. Now, here's what I know about this one. Oh, number of roots hits the x-axis. I'm not asking what they are. I'm just asking how many. In this case, there's 2. What do I got here? All right, so I'm not exactly sure what's going on here. So this one also has a y-intercept of negative 1. It could go like this. Now, why is it coming down? It's coming down because my leading coefficient is negative this time. You guys should have a pretty good handle on that. Is it going to go like this? Is it going to go like this? I don't know. I know it's skinny because it's a 2, but I don't know which one of those it's going to do. Only thing I know is that it's got a y-intercept of negative 1. By the way, you should recognize that's the y-intercept right there. All right, so let's go to the graphing calculator. So the only thing it's got to do is change the negative, the front into a negative. So I'm going to hit the tab button. I'm going to hit the up arrow. I'm going to hit the tab button. I'm not going to use my pen. I'm going to use the tab button. Tab button. Hit the up arrow. And then all I'm going to do is go to the front. And the only change I made was I put a negative out front. Put a negative out front, hit enter. So now you'll see. Now we got a little bit of an issue here. Now we got a little bit of an issue. In this case, I have no roots. Well, let's say this. I have no real roots. There are some imaginary roots. You just have to imagine they're there. But there are some probably imaginary roots. But there are no real solutions to this problem. So As far as domain and range goes, it goes forever and ever to the left. It goes forever and ever to the right. Let me draw this thing in here. It's going to go like this. So I was just wrong on which side of the y-axis it was, but it draws like that. So the domain is negative infinity to positive infinity. Hopefully this stuff is not behind my big head. Now the range, I'm going to just be a little bit more generic now. Instead of having to actually find that value, mostly because it's irrational anyway, I'm just going to say the range, as far as this one goes, is from negative infinity to the maximum. Now in this case, because it's irrational, I would have to probably round it or give it in its radical state. So I might do this. If I have to round it, I would maybe do that. Or if I gave it to you as a radical, I would put a bracket there. So sometimes you want a bracket, sometimes you want a parenthesis. But what I want you to remember is this would be a maximum. Now over here, because this is down here at the bottom, this is really the minimum, comma, infinity. And when it's a maximum, when this is the top here, when this is the biggest value, when the vertex is the top point, then it's from negative infinity to a maximum. And in this case, there's two imaginary, can you see that? Two imaginary roots or solutions, okay? Only because it doesn't hit the x-axis. In this case, there were two real solutions. All right, so what do I want to say? I thought I had a nice fancy little. Here's one of the things I want, as far as you to know, is that the number of roots is equal to the highest degree. Or how about the degree of the polynomial? So the degree of the polynomial, should have made that bigger. The degree of the polynomial is whatever the highest degree is, or whatever the sum of the degrees are. That's later. Let's just worry about this. 2. So the most you're going to have is 2 solutions. 2 real solutions. Here the degree is a 1, so you have 1 solution. Again, here you have a 2, so you have 2 solutions. In this case, they're imaginary, but they do have 2 solutions. So let's take a look at this function right here. Now, I don't need to graph it on my graphing calculator because I've given you a picture of what it looks like. You'll notice that in this case, it's got a degree of 3. A degree of 3. So this is what the cubic function looks like. This is basically the generic cubic function. If I was just to graph y equals x cubed, that would just go kind of like this. Get a little bend in the middle and bend up. So this one's pretty close to what the generic cubic function looks like. It just has a y-intercept of -1, which is why it passes the y-intercept right there, crosses the y-intercept right there. You'll notice, as far as the domain goes, it looks like it's going forever and ever to the left and forever and ever to the right. Now, remember, you got to imagine there's arrows here. And it's just going to keep going a little bit more to the right, 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 a little bit more to the right. But it just, even though it's going slow, it is going to the right. So the domain for a cubic function is going to be negative infinity to positive infinity. Now, the range, you'll notice the range goes for, and this was clear to see, forever and ever up and forever and ever down. So the range of these is also from negative infinity to positive infinity. Now, it doesn't matter if your leading coefficient is positive or if your leading coefficient is negative. The domain and range are always going to be the same. Negative infinity to positive infinity, negative infinity to positive infinity. Remember, low number on the right, high number on the left. Low number on the left, high number on the right. And it should make sense. Low, high, always. Well, cubics always go up one way and down the other way. So can you see the difference between these two? When it is a positive leading coefficient, it's going in from left to right, it's going in an upwards direction. When it's got a negative leading coefficient, notice it's going in a downward direction. So for example, and I always tell my kids, if I have arrows on the end of these graphs, and I just draw a linear function between them, would that slope be positive or negative? In this case, it would be negative, so your leading coefficient is going to be negative. Over here, if I draw an arrow between these two, which is kind of what I've done, if I draw a straight line in between the two arrows here, that slope would be positive, so your leading coefficient would be positive. Let's answer a couple of questions about these. Is it a one-to-one function? Now remember, a one-to-one function has to pass both the vertical and horizontal line test. Passes the vertical, no matter what. It gets steep, but it still passes, and it passes the horizontal. So in this case, this one is yes. How many real solutions does it have? Now the key on this one was the word real solutions. Now according to my graph, I just told you the number of roots equals the degree of the polynomial, but that accounts for real and imaginary. In this case, based on the graph, there's only one solution. Even though it will have a maximum of 3, that means 2 of them are imaginary. So it has one real solution, and then it would have 2 imaginary solutions. Now this one is also of degree 3, but based on the characteristics of this one, based on all this other stuff that's going on here, it's going to pass the x-axis 1, 2, and 3. So this one has 3 real roots. Now, is it a one-to-one function? It is a function. It does, in fact, pass the vertical line test, but it fails the horizontal line test. So it is not a one-to-one function. So the answer is no in that case. All right, let's keep moving. Let's talk about a 4th degree polynomial. And then we're going to bring this all together at the end. So don't think you have to have this memorized right away. We're going to bring it all together at the end. So if you're sitting there going, what is that crazy bald guy doing? And I wish he'd stop drinking coffee because he's making me so jealous. I'll bring it all together in a minute. Remember, think about there being arrows here. So this is an even function. Even function. The domain. Now, this looks like it's going straight up. It's not. It's going just a little bit to the right, little bit to the right, little bit to the right. So, this is going to the right very slightly, but if you go all the way to infinity, it will just keep going to the right. And this one is clearly going to the left. So my domain for this one is negative infinity to positive infinity. Now, range, we're going to be kind of, I'm not going to graph this one or look at it, but range, I want you to get a good handle and good idea or understanding of this. The range is the lowest y value up, going straight up. So I'm just going to write over here min, comma, infinity. Now again, it could be a bracket, could be a parenthesis there, but I want you to write min to infinity. Now, what does it look like approximately? Like if I had to approximate this, I'd say, oh, it's approximately what, negative 2.3? Negative 2.3 to infinity. Something like that. I don't know exactly what it is. Let's answer these questions at the bottom. Is it a one-to-one function? Does this pass both the vertical and low? I should probably ask you, just as a reminder, is it even a function? Well, yeah, it is. It passes the vertical line test. You got to remember, if I draw an exact vertical line in here, I'm only going to hit it once here. I know it looks like a vertical line, but it's not. So yes, it is a function, but it is not one-to-one because it fails the horizontal line test. And how many real solutions does this one have? This one has. Now, it could have a maximum of 4. It could have a maximum of 4, but in this case, I only have 2. So for that question down there, write a 2. All right, let's slide over to the right. All right, so the only difference between that one and this one is it has a negative leading coefficient. So it is a degree polynomial 4. Notice it's going down in both directions. Going down in both directions. So its domain is from left to right, still going forever and ever and ever. I guess when all else fails, guess the domain is negative infinity to positive infinity. It's usually the range that's going to be the more difficult one. So in this case, again, it's always low on the right, high on the left, right? So on this one over here, the low was down here, and the high was way up at the top. This one, the low is way, way, way down there somewhere, and the high is right here. So if I have to do range, low on the left, high on the right, I'm going to go negative infinity to whatever the maximum is of this graph. And that's that point right there. I don't know. Looks like maybe 3.7. I don't know. I mean, I certainly could graph this thing and find it. We could do that real quick. Let me do that real quick. Let's get rid of this. So negative x to the fourth, x raised to the fourth. Get out of the exponent mode. Plus 3x cubed out of exponent mode. Plus x, escape, x squared. All right, let's try that again. Plus x squared. Minus 4x, minus 4x, minus 1. Hit enter. All right, so that kind of looks like what we got on our graph. Let me get rid of that. I don't need that anymore. And again, I want to know what that maximum is. I want to know what that maximum is. So I go to Menu, Analyze Graph, Maximum. Click, click. So that maximum, remember, we're looking for the y value, is 3.6122, but it's probably irrational. It probably is irrational. So it's 3.6. So I said 3.7, but there it is. We could find it if we have to. Is it a function? Yes, it is a function. It passes the vertical line test. It is not a one-to-one function. Fails the horizontal line test, so no. And the next question, it says, how many real solutions does it have? Well, it can have a maximum of 4 solutions. And in this case, it does. 1, 2, 3, 4. So in this case, down here at the bottom, you'll write 4. Man, I just saved that, and I want to apologize. My audio and my video got a little bit off. It's so weird when the audio and video get just even slightly off, and then you sound like this, talking like this. It's like an old karate movie from like the 70s where the sound and the audio doesn't match. All right. So now we've got a 5th degree function. This is a 5th degree function. Notice what's going on here. Now it's going down in this direction and up in this direction. Let's talk about domain and range. Negative infinity, positive infinity. And then range goes down forever and up forever. So range for these are pretty easy. Negative infinity to positive infinity. Is it a one-to-one function? No. How many real solutions does this one have? Well, it has 1, 2, 3. So 3 is the answer to that question down below. Now it could have it could have a maximum of 5. So if it has 3 real, then more than likely 2 of these are going to be imaginary. You just have to pretend they're there. That's not exactly what it means, but all right. Now notice this has a negative leading coefficient. Let's answer the questions. Negative infinity, positive infinity. Range, same thing. Negative infinity to positive infinity. But is it a one-to-one function? No, it fails the vertical line test. And then how many roots does this one have? This one also has 3. This one has 3 real roots, so 3 goes down there. Now again, notice that the leading coefficient is negative, and it's going up and down. And again, if I plot that line that goes between those 2 points, it has a negative slope. If I go over here and I plot the line between these 2 arrows, notice it has a positive slope. This is why this is a leading coefficient that's positive. So let's break this all down. This is what I want to make sure you understand. First things first, I want to talk about this. The degree of this polynomial is 1. The degree of this one is 2. The degree of this one is 3. The degree of this one is 4. And we actually went up to a 5th degree polynomial, and I might throw that off the side a little bit. So, when a linear coefficient, if it's positive, if the leading, this should say the leading coefficient, the leading coefficient, if the leading coefficient is positive, then it's going to look like this. If the leading coefficient is negative, it's going to look like that. Now, if it's a quadratic or a squared function and the leading coefficient is positive, you should know this is going to be a parabola that opens up. If it's negative, you should know that it's a parabola opening down. Now, a cubic, now if we go back to that cubic function, that third degree polynomial, remember, on a third degree polynomial, you'll notice that if it's positive, it's going in the general up direction, and if it's negative, it's going in the general down direction. So if I go back to this sketch, and then it should, because it's a cubic, it shouldn't look linear. It should have a little wiggle in it. So the general shape of a cubic is just this. But since it's positive, it's going in this upwards direction from left to right. And if it's negative, it's just going in the little curvy curve in there. And it's going in that general downward direction. Now, quartic, that's a fourth degree polynomial. It's got the same characteristics of a cubic, of a quadratic, of a second degree function, in that when it's positive, it's going to open up in both directions. Now, or it's going to go up in both left and right, but it generally has a few more wiggles in it. Does it look like that? Sometimes. If it's negative, it's going down in two directions. So it might look like this. So you should start to generalize. One of the things you should start to generalize and start to get an idea on is if the leading coefficient is odd, it's going to go up and down. Now, it'll go up and down based on whether or not it's positive or negative. If it's positive, it's going to go up generally, and if it's negative, it's going to come down generally. With the even functions, the 2, the 4, the 6, the 8, if it's positive, you're both going up, and if it's negative, they're both going down, So as it goes to the left and right, they go down. If it's negative, as it goes to the left and the right, it goes up if it's positive. Odds and odd functions are always going to go up and down, either way if it's positive or negative. So that's called end behavior. This is called end behavior. Now, what do I mean by end behavior? End behavior happens at the arrows. What happens at the arrows? Or as it goes to the left and as it goes to the right, what happens? So, positive, oh, sorry. I missed a word. I didn't see the word odd. It was driving me crazy. So, if you have, so all I want you to do is, by the way, this is Miss Newman's caricature. I'm not sure how she made this, but she made this. This is Miss Newman's caricature. So if you have a positive function and it's odd, first of all, you should start to recognize, oh yeah, odd goes up and down or down and up. So if it's positive and odd, now I don't want you to sketch. I'm not asking you to sketch. I want you to describe the end behavior. So it's kind of hard to do without a sketch. So I'm going to draw a little quick sketch. So positive odd looks something like this, right? Isn't that got like a positive slope? And it's odd, so it's going in opposite directions. Okay. So now we're going to talk about what end behavior. So here's how you describe it. As X arrow. It's a terrible arrow, so let me draw that. You don't need to make it that long. As X approaches positive infinity. This thing right here stands for approaches. So as your teacher reads it to you, they're going to say, as X approaches positive infinity, what's Y doing? Y approaches. So as X goes to the right, what's Y doing? Oh, it's going to positive infinity. As X approaches negative infinity, what's y doing? So as x goes this direction, isn't y going down? So y approaches negative infinity. Negative odd. And again, I like to draw a quick sketch of what these things look like. So I'm just going to draw a quick sketch. Negative odd points in opposite directions, and it's coming down. So if I'm going to write this one as x approaches positive infinity, and by the way, what I mean by that is goes to the right, right? Isn't x going positive infinity going to the right? I hope that's to the right for you. It's to the left for me. But so as x goes in this direction, to the right, y is going down. So y approaches negative infinity. As x approaches negative infinity, or as x goes to the left, y is going to, or y approaches positive infinity. Even. Now the easiest even one is a parabola. So if it's a positive even or a positive parabola, it goes to the left and the right. So as x approaches positive infinity, as x goes to the right, y is going to positive infinity. Wait, aren't both y's going to positive infinity? Yeah. As x approaches the left, oops, this should be negative infinity. As x goes to the left, negative infinity, y is approaching positive infinity. And you need to put that positive. Actually, the positive is not necessary. The negative is definitely necessary because you need to understand. So because it's even, whenever it's an even function, they're either both going to go up or they're going to both go down. If it's positive, they're both going up. The y's are both going up. If it's negative, the y's are both going down. So on this next one, it's just a parabola going down. So as x approaches positive infinity or negative infinity, y is going down. So y approaches negative infinity. As x approaches negative infinity, so as x goes to the left, y is still going down. So no matter what, both y's are going down when it's negative, and both y's are going up when it's positive. They don't know how much I love you. Or maybe they do. Let's talk about N behavior. No, that's not. All right. So this stuff's not that bad, but it's easier if you draw a quick sketch. So if it's an odd function, it's going up and down or down and up. Up and down and up. So I always think about it as being a line. Even though it's a cubic, it's a line. So I know it's got a negative exponent, but this odd, so remember a linear function's got a degree of 1. So when it's negative, it's coming down. So I know it's coming down. I'll put a little bump in it just to make sure it's so that's a cubic function coming down. Actually, that looks like some little kid threw up on the paper, but whatever. So think about it this way: as x goes to the right, positive, and this first one is negative. As x goes to the left, y is going up. Why I keep putting those parentheses there? As x goes to the left, y is going up. As x goes to the right, y is going down. So y approaches negative infinity. Again, we have an odd function. I don't care if this is a 5, 7, 17, 31. It doesn't matter. It's still going to have the same general shape. You can have a degree of 401. Who the heck would ever have that? But as long as it's odd, I know that it's either going to be going down and up or up and down. So you have to decide. Well, because my leading coefficient is positive, I know it's going to look something like this. Is it going to look exactly like that? No, it might look like this. I don't know. But what I know is at the arrows, because it's positive, at the arrows, it's going to be going like this. So that's all you need to know. So as I go to the left, the y's go to negative infinity. As I come to the left here, let me get rid of this one. I'll get rid of these two. As I go to the left, so I get you more to look at it, it's going down. As I go to the right, it's going up. So y goes to positive infinity. Maximum number of roots. In this case, the maximum number of roots is 3. The maximum number of real roots is also Oh, the minimum number of real roots. God, I was wondering what the heck that was. The minimum number of real roots, it has to pass the x-axis. It has to pass the x-axis. So the minimum number of roots is 1. And the reason it has to pass over the x-axis is because odd functions are always going up or down. So it has to pass the x-axis. In this case, the maximum number of roots is 5, but because it has to pass the x-axis, it may pass it 5 times. It may go and go, okay, there's 1, 2, 3, 4, 5. But it may only pass it once. Maybe all the wiggling stuff is up there, but at least it passes it once. All odd functions have to have a minimum of 1 and a maximum of whatever the highest degree is. So in that case, that with that. We'll talk about these. These are a little bit different. So this is an even function. Anytime it's an even function, my brain goes back to, okay, it's got the general shape of a parabola with maybe a few extra wiggles. Bumps, relative mins, relative maxes. Those bumps are called relative mins and relative maxes. So this is a 6th-degree polynomial. And it's got a negative leading coefficient, so I know it's pointing down because it's negative. Now, will it look like a parabola? No. It'll probably have a few extrema, which are called extrema. Maybe it looks like that, where you got some maximums and some minimums, some relative max, relative min. You'll cover that in pre-calc next year, but who cares? I'm just asking you about end behavior. So as this goes to the right, it goes down. As it goes to the left, it goes down. So my end behavior, as x goes to the left, y goes down. And as x goes to the right, y goes down. Maximum number of roots is 6. The minimum number of roots, believe it or not, is 0. Now, why could it be 0? Well, remember, this could be a 6th-degree polynomial that does this. And because it points either both down or both up, if the whole thing's below the x-axis, it's not going to have any roots. If the whole thing's above the x-axis, raising the roof, it's not going to have any roots. So it could have no roots. Could. All right, I've got an 8th-degree polynomial. I don't know what an 8th-degree polynomial is. I have no idea. So I'm not even going to try to bother graphing it. But I know it's a positive and it's even. So I know it's going to look like a parabola going up. Now, I know it's going to have some bumps, some relative mins and relative maxes. I don't care. I know it's going up. So as it goes to the right, it's going up. As it's going to the left, it's going up. The number of maximum roots is 8. And the minimum, again, would be 0. Again, if this looked like this, if this is a parabola that looked like that, or, you know, an 8th-degree polynomial that had like 17 bumps in it, whatever it looks like, it may never actually touch the x-axis, so it could have 0 roots. Notice with the odd functions, these are going to be different. One's going up, one's going down. One's going up, one's going down. With the even functions, they always go in the same direction. They're either both going up or both going down. And what determines that? The leading coefficient. Is it positive or is it negative? All right. All right, so hopefully you're getting a better handle on this. We'll go through this page real quick. All I want to do on these problems, I want you to tell me whether or not the degree is positive or negative, or I want you to tell me whether the degree is odd or even, and whether the leading coefficient is positive or negative. All right, so since this one goes in opposite directions, the degree is odd. Has to be odd. It's got to be a 3. It can't be a 1 because it's got some relative mins and maxes. A 1 would be a linear, so it's got to be a 3, a 5, a 7, something like that, because it goes in opposite directions. Now, I like to draw a line in between these arrows because it's like a linear function. And isn't this slope negative? That means my leading coefficient is going to be negative. These are pointing in the same direction. So my degree is even. and they're both pointing up. And just like if it was a parabola that both pointed up, you know my leading coefficient is positive. By the way, now that I've done 2, you probably understand what I'm looking for. See if you can do the other 4 that are on this page. Pause it and see if you can do the other page. Do these 4. Same idea. Okay, hopefully you're back. A polynomial with a leading coefficient that's negative, and the highest degree is 4. That's even, and it's negative. That means that it's pointing down. I don't know what else it's going to do, but it's pointing down. The reason they're both pointing down is because it's even. So they're both going to point either down or they're both going to point up. And since it's got a negative leading coefficient, they're both going to be pointing down. It might look something like this. Some bumps. Something like that. Let's go over here. A polynomial with a leading coefficient that's positive and it's odd. Now, odds are going to go either up and down or down and up. So, but because it's positive, I want the one that's going to have a positive slope. So I know I'm going up in this direction and down in this direction. I don't know what it's doing in between, but I know it's going to have some bumps. Something like that. Sketch a graph of an even degree polynomial function that has no x-intercept. So I'll give you a couple of different examples. Parabola. Fourth degree function. Something like that. Anything like that will be okay. And finally, can you sketch a graph where an odd degree polynomial with no x-intercepts? Now don't forget, an odd degree means it's going up in one direction and down in the other direction. So if I was going up in this direction and down in this direction, somehow I've got to connect those 2 points. It could be that it's going up in this direction and down in this direction. So somehow I got to connect those 2 lines. As soon as I connect those 2 lines, I don't care. Oops, that's terrible. As soon as I connect these 2 rays that I got, it's got to look something like that, or it's got to look something like that. But as soon as I do that, I know that it has to pass the x-axis. So can I? No, you can't. It must have at least 1 root. So all odd functions must have at least 1 root because they're going in opposite directions. So it has to pass the x-axis. Even functions, not necessarily. All right, kids, that's it. Catch you on the flip side. Goodbye. Thanks for coming.